Determine all real numbers for which x squared plus 2x minus 8 is equal to 0. So we have x squared, we can factor that, x, 4 and 2, and I think positive, negative would do it, and therefore x is either equal to negative 4 or it is equal to positive 2. Determine the values of b and c for which the parabola with the equation y is equal to x squared plus bx plus c passes through 1, 2, and 2, 0. So we're going to substitute this and this into this. And when we do, we get the following equations. Let's do it up here. We get 2 is equal to 1 plus b plus c. And we also get 0 is equal to 4 plus 2b plus c. So those are the two equations. And I think that will allow us to solve this. So this basically will be 1 is equal to b plus c, and therefore b is equal to 1 minus c. And then we can substitute that in there. So 4 plus 2b, which is 1 minus c from here, plus c. And then you guys can solve that. I'm certain of it. And when you do, you get c is equal to 6. And then substitute that back into here to get b is equal to negative 5. A ball is thrown from a window at the point 0, 2. The ball flies through the air along the parabola with the equation y is equal to a times x minus 1 squared plus 8 over 3 for some real number a. Determine the positive real number d for which the ball hits the ground at d0. Same story, I think. Not much difference. Just a little bit more wording. They've given you 2 points. And you're going to have to sub it into this equation. So let's sub in the 0, 2 first. So we get y is equal to a, 0 for x, plus 8 over 3. And that, let's see, what does that do? It just gives you a, right? Yeah, it just gives you a. Oh, wait. I got to sub in my y value. When y is 2. So I should have put 2 in there. I almost forgot that. So 2 is equal to a over 3. A plus 8 over 3. And therefore a you can easily solve. It'll be minus 2 over 3. Okay, so that's pretty quick. We got that. And then now the next step, I guess, would be to just plug this guy into the equation, this equation. Okay, so let me see. This time I actually do it properly. Y is 0 this time, and x is d. And a we figured out was minus 2 over 3. So put in that d for the x. And I think there you go. And then we have only one variable in this equation, so we can easily solve for that one variable. So I'll put this on one side. 2 over 3 d minus 1 squared is equal to 8 over 3. The 1/3 will go, and the d minus 1 squared will be 4. I take the square root of both sides, so d minus 1 is equal to 2. I'm confident that d is positive just because it's here, right? It's obviously on the positive side of the x-axis. And therefore, this leads to d is equal to 3. Joe plays a game using some cards, each of which is red on one side and green on the other side. To begin the game, Joe selects integers k and n, with 1 less than or equal to k less than n. He then lays n cards on the table in a row with the red sides all facing up. On each turn, Joe flips over exactly k of the n cards. Joe wins the game if, after an integer number of turns, he has flipped the cards so that each card has its green side facing up. For example, when n equals 4 and k equals 3, Joe can win the game in 4 turns as shown. So they're giving you a little example there. All right, when n is 6 and k is 4, show that Joe can win the game in 3 turns. Okay, so assuming you understand the question, I will go ahead and do it. So we have to show that, so what is it? 3 turns. Okay, so we got the start, and then we have turn after turn 1, after turn 2, and after turn 3. Okay. Let's see if we can do this. So we're starting with n equals 6, right? So there's 6 of them in the beginning. So R, 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 R. And then k is 4, so that represents how many we have to flip. All right, let's see here. Let's flip these guys, the first 4, so they become G, 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 and these remain R, R. Okay. Now the next one, we'll flip the middle 4, and that'll be G, R, 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 G, R. And for the last one, we'll just flip the R's to make them back into G's. G, 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 G. So there you go. That shows that in 3 turns, he can win the game based on the definition of how you win, which is having all the green sides facing up again. Now we get into n equals 9, this time k equals 5, show that Joe can win the game. And this is basically the story about how Joe can win. I'll explain it to you. Initially he starts with 9, right? This is 9 cards. And initially they are flipping over 5, so they're going to flip over these 5, and that's why they turn to G. And then they'll flip over, let's see, the next one, 1, 2, 3, 4, 5, so the middle 5. And then finally you're going to flip over this guy, this guy, this guy, this guy, and that guy. Yeah. So as you can see, very similar to what we did up here. The only difference is now it's n equals 9 and k equals 5. So that's all there is to this question, really. Consider a function f with f at 1 equal to 2 and f at n equal to f at n plus 3n for all positive integers n. When we substitute n equals 1, the equation f at n equals f at n plus 3n becomes f at 1 equals f at 1 plus 3 times 1. Since f at 1 is 2, then f at 2 would equal 2 plus 3, which is 5. Continuing this way, we determine the value of f at 26. Determine the value. Okay. All right, so here we go. F at 1 is 2. That's given in the question. And then we just kind of do this recursive pattern here using this equation over and over again. So we're going to use f at 1, I guess. So when n equals 1, this would be f at 1 is going to be f at 1 plus 3 times 1, which I think they already did. So f at 1 is 2, and this is 2 plus 3, which is 5. So they already did that one right here, actually. So I could have started with that, but that's okay. I just wanted to show you. And now we just use that equation again. So this time will be f at 2 is equal to f at 2 plus 3 times 2. And that looks like f at 2 is 5, so f at 5 would be, f at 2 is 5 plus 6, so that's 11. All right, so now we have n equals 5. We can jump to n equals 5. That's good. I mean, because 26 is a long way if we have to keep doing it one by one. But we can jump to 5. So we have f at 5 this time is equal to f at 5 plus 3 times 5. And that looks like f at 11 is equal to, what was f at 5? 11 plus 15, which is 26. Aha, we got the 26. Oh, no. Wait, hold on. No, we still got to use n equals 11 here. I got a little excited there. Okay, so we have f at 11, and that would be f at 11 plus 3 times 11. And that would be f at 26. Okay, there we go. And that's what I thought what would happen. 26 plus 33, and that is 59. So f at 26 is 59. So you got that by doing that formula recursively again and again. Prove that there is no function with g at 1 equal to and g at n plus m is equal to n plus g at m for all positive integers n and m. So similar, I think. I don't think there's anything too different here. We're given some very basic stuff, and then we're given this equation here, and that's pretty much all we have to work with. So let's just try n equals 1 like we did, and then m equals 1 and see what happens. So g at 1 plus 1 is equal to 1 plus g at 1. So that's 1 plus 2 is equal to g at 2 plus 1. So g at 3 is equal to 3. Okay. I don't know if that helps in any way, but we got that. A fact. So let's try m equals 3. Since we can move along now. G at 1 plus 3 this time equals 1 plus g at 3. Right? I chose 3 because that's what we have. Just like up there, I had chosen whatever numbers we had gotten to help us skip along a little bit. And then what do we have here? G at 1 is 2, so 2 plus 3. This is 1. G at 3 is 3, so g at 5 equals 4. All right. Let's keep going here. Next one would be n equals 3 and m equals 1. So g at 3 plus 1 is equal to 3 plus g at 1. So g at 3 is 3 plus 1 is going to be 3 plus 2. So g at 4 is equal to 5. And you just continue this way. And you guys can do this. For n equals 3 and m equals 2, what you'll find is g at 2 equals 1, which is fine. And then for n equals 2 and m equals 4, you will get g at 5 equals 7. But this is a contradiction to what we found here. See, those two are telling me two different things. So since that is a contradiction, it shows me exactly what they're asking in the question, that there is no function with all these things because we were able to find a contradiction.